everyone, my name is Liu Hong. So today I will teach you guys GCD of polynomial. So what is GCD of polynomial? Okay, so suppose that polynomial fx and gx, then we will say that polynomial dx is the highest common factor of fx and gx. Then if polynomial dx is a factor of both fx and gx, and also hx is also a factor of fx and gx, then hx is a factor of dx. So this is a theory that we should know before we go through another question. So now prove that GCD fx gx is multiple of GCD gx rx. So let hx be GCD of gx and rx. Okay, since fx is equal to qx gx plus rx, then as we know, hx divided by fx, then hx is a common factor of fx gx. So by definition, just now we have learned hx also divided of GCD fx gx. Then continue. Since rx is equal to fx minus qx gx and rx divided by rx as well. So rx is a common factor of fx gx as we know. By definition B, just now we have learned hx also divided of gxc, GCD gx rx. So the question is proven. So next, go to the example 1. So now let's do this question. Find the GCD of fx and gx. So here I have gx and fx. Then by just now the theorem we have learned, GCD fx gx can be written as GCD gx and rx because the multiple doesn't affect the GCD. So let's turn the fx into something gx. Okay, so we have already divided the fx, then we get half, then plus the remainder x squared plus 4x. So let's continue. Input the value into it, f squared plus 4x. So we need to divide the gx by the remainder just now we have get. So it's 2x. So the remainder is 0. That means it's get completely divided. So as we know that GCD fx gx can be written as something multiple GCD gx rx. So this doesn't affect anything. Here doesn't affect anything. Then also we will get the GCD of fx gx is x squared plus 4x. The question is complete. So now here is a theorem that we should need to know. Give any two polynomial fx and gx, there is a polynomial dx which is the greatest common divisor of fx and gx. Moreover, there exists polynomial ux and vx such that dx equal to ux fx plus vx gx. So if GCD fx gx is equal to 1, then fx and gx is relative prime. Now another theorem. Two polynomials fx and gx are relative prime if and only if there exists polynomial ux and vx such that 1 equal to ux fx plus vx gx. Example. So let's see this question. So show that fx and gx is relative prime. Here is fx and gx. So now let's simplify it. So we can see if they have any factors, same factors. So same, simplify of x, then we'll get x squared plus 5x plus 4. Then continue simplify, x plus 1, x plus 4. Now turns gx. So this we can get x minus 1, x minus 4, and x minus 3. So as we can see, they didn't have any common factor, so they are relative prime. So GCD fx(gx) is equal to 1. They are relative prime. So the question is done. So now is another proof that we should need to know. If fx, gx and hx are polynomials such that fx divides gx hx and fx and gx are relative prime, prove that fx divides hx. By given fx divides gx hx, so we can write as fx px is equal to gx fx. This is our first equation. First, since fx and gx are relative prime, so axis of ux and vx. 1 equal to ux fx plus vx gx. So now let's multiply hx both sides, so we will get this. So this will become our equation 2. So substitute equation 1 into equation 2. So we will replace the gx hx into fx px. So we can simplify out the fx. Then hx is equal to fx ux hx plus vx px. So as we can see, hx can be divided by fx. So the question is being proven. So now let's prove that if fx and gx are relative prime polynomials and hx is a polynomial with degree h smaller than degree f plus degree g, there exist two polynomials ax and bx with degree a smaller than degree g and degree b smaller than degree f, such that hx equal to ax fx plus bx gx. The polynomial ax and bx are unique. So now let's prove it. So now let's prove this. Okay, firstly we know that fx and gx is relative prime. So we will get 1 is equal to ux fx plus gx vx. Then let's multiply hx both sides. Okay. Then we'll get this. Okay, right. Then because there's some cases that the degree of the ax and bx will be very big. So we divided the hx ux divided by gx. So hx ux is equal to qx gx plus rx. So the rx actually is ax. Okay. Then as this equation, then we will know that actually the degree of a will smaller than degree of g. Absolutely. So here we have hx ux. We can sub into here. So now let's try. Okay, hx will equal to qx gx plus ax fx plus gx vx hx. Then let's simplify it. Fx qx gx plus ax fx plus gx vx hx. So we need the term of fx and gx. So let's just simplify out fx and gx. So gx vx hx plus fx qx, then plus ax fx. Okay, right. So here have ax fx, here have gx and a lot of function. So let this function be bx. Let bx equal to vx hx plus fx qx. Okay, alright. So let's continue. Degree h must be smaller than degree g plus degree f, as we know at the question. So degree AF must be smaller than degree A is equal to degree A plus degree F. This is a assumption, some cases. Okay, so then also smaller than degree G plus degree F. Why? Because degree A is smaller than degree G. Okay, let's continue. Because we have set this assumption, so degree AF actually is degree BG. How it's come from? Degree A plus degree F is equal to degree B plus degree G. Then let's continue. Degree BG will also smaller than degree G plus degree F. Then degree B plus G plus degree G will smaller than degree G plus degree F. Okay, from the definition that we learned before, okay, here we can cancel out the degree G. Then degree B is smaller than degree F. So both degree we have proven.